Alright, so I partitioned 80 gigabytes to dual boot Arch Linux on my laptop, and then I chose to use KDE Plasma as a desktop environment for its ease of use. And here's just the build steps for it. Making a build directory, then cmake, and then make. Um, and then we're gonna go into the bin directory, start the sender first, like on Linux for the IPC, and then the receiver is the main program that I wrote. The sender is just like to actually communicate and to simulate that. So you see, it logs the threads that I started on the main program, and you can see the write program just continuously sends messages and reads from a CSV and then sends it over IPC. And then on the left is the main program, which is updating the UI and also processing, technically creating vector embeddings, which are not actual embeddings, but it's room for improvement later. And giving the three most recent added messages from um, the sender. And then you can see it stopped successfully and shows all the threads that stopped in the main process. All right, so in my main file, I basically start kind of in order from the data flow. So I start the message queue, the concurrent hash map, and then I deploy the IPC manager, which reads from the IPC channel and then appends the messages to the message queue. And so the message queue is also available to all of the worker pool threads, which basically you can define how many you want. I set it to 6 so that I meet the requirements of 10 or more threads for the project. But the worker pool reads through the message queue, um, removes messages, and then adds them and sends them to the fake like vectorizer, which is just um, as a placeholder for actual vector embeddings. Receive them, create them, cast them to vector embedding objects, add it to a concurrent hash map to kind of group them together. And then this concurrent hash map is also used by the UI updater to take snapshots so other operations can keep going. So basically, there's the main categories of threads I have. The IPC manager, which is responsible for actually like reading from the IPC channel, adding adding them to the message queue. Then the worker pool thread is responsible for reading from the message queue, and then like handling like doing more computationally intensive tasks, and then the UI updater is responsible for updating the UI. So really there's about three different tasks going on concurrently.